All right, guys, how you guys doing today?
Good.
Good. All right, so today I want us to work on our one-step equations that we were working on in Foundations Math, okay? The reason that I want to continue to work on these equations here in this math lab is so that we can continue to become more comfortable with what we're doing, and that we can continue to practice so that we have that confidence in what we're doing, okay? So today we're going to actually go through some addition, subtraction, multiplication, and division, one-step equations, similar to what we did this morning in math class. We'll watch some videos that correlate with what we're doing, and then we'll do that kind of as a group. Then we'll have some independent time at the end. Okay? Are you guys ready to get started?
Yeah.
Mm-hmm. All right. I do have this video, and you got to understand that during the course of the video, I'll actually stop and have you guys go to the board, and we'll, talk through some things. Okay?
So let's say that you have x plus 7 is equal to 10, and I want to solve for x. All it's saying is something plus 7 is equal to 10, and you might be able to figure out in your head, but if you want to do a little bit more systematic, you're like, well, all I want on the left-hand side is an x. Well, if all I want...
Okay, so as we're going over this, when we have a variable, where x is our variable right there, we're trying to solve for x. Do you guys agree?
Yeah.
So as we're solving for x, what do we have to do to solve for x? What's the first step?
You will take -7.
Why are we doing -7
Because
here?
it's
Ashley Newton,
opposite
please come to the
of
office.
addition.
It is the opposite of addition, or we're going to call that an inverse operation, which is one of the vocabulary words that Mr. Becker in math class went over. Inverse operation. So we have an addition of 7 here. We're going to subtract 7. Now, do we only just subtract 7 right here?
No, you do it to the other side.
We do it to both sides. Okay, so I'm going to subtract 7 from both sides. Do you
Yeah.
agree with this? Okay. Now, one of the things that I want you to get in the habit of is crossing that out, because we basically have eliminated that.
Yeah.
Do we have x by itself right now?
No.
We don't?
Oh yeah, yeah.
Yeah, we do. Okay, so we have x by itself. So I'm going to go ahead and come over here. I'm going to go x will be equal to 10 minus 7, or x is equal to 3. All right? Now, how would I check to see if this is correct?
You will put the answer for the variable on the problem. Like you will do 3 plus 7.
Yeah, I can plug this number right back into my equation. So I have 3 plus 7 equals 10. And we know that that is the correct answer. Would you agree?
Yeah.
All right, so let's finish watching this section of video.
One on the left-hand side is an x, I'd want to get rid of the 7. I want to subtract 7 from the left-hand side. But if I want to maintain an equality here, whatever I do to the left-hand side, I also have to do to the right-hand side. Going back to our scales, that's so that we can keep our scale balanced. So we can say that the left is still equal to the right.
So he just shows right there that if we're going to subtract 7 from one side,
You
we're going to...
subtract to the other side.
Excellent.
And so what we're going to be left with is x, and then the 7's cancel out, is equal to 10 minus 7 is equal to 3. So that unknown is 3. And you can verify it. 3 plus 7 is indeed equal to 10. Let's try one more.
Okay, so we do have the correct answer. All right. Now, one of the cool things about this is Khan Academy. And Khan Academy is a great supplement to our math classes. And if you happen to be gone, you can use Khan Academy to catch yourself up. It's just exactly what we've been doing in class. The man, the voice in the background, he can walk you through what you need to do. So this is a great supplement. So if you do happen to be gone, you can either, ask Mr. Becker for help, you can ask me for help, or you can even watch, these types of videos. okay? So should we go on and check out the next part
Yeah.
of the video? So I'm gonna erase what I did, okay? And then I think we'll have one of you guys go to the board.
Or let's say we have a minus 5 is equal to negative 2. So this,
Okay, so there's our equation. A minus 5 is equal to negative 2. Do one of you want to go to the board and work this one out? Go ahead, Connor. Okay, so you rewrote the equation out, okay? So what's your first step, or what are you thinking? Okay, so why did you add 5 to both sides?
Because this is a minus.
That is a minus. So think about a vocabulary. Inverse operation. So the opposite of subtraction is?
Subtract.
The opposite of subtraction is?
Plus.
Addition,
Addition.
right? So what do you need to do with the plus 5 and minus 5? We're crossing them out, right?
Mm-hmm.
Okay. A equals 3. So minus 2 plus 5 is 3. Sound good?
Mm-hmm.
All right. What do you think, Lily?
Yeah.
Okay. Let's check it out.
is a little bit more interesting since we have all of these negative numbers here, but we can use the exact same logic. We just want an a over here on the left-hand side, so we have to get rid of this negative 5 somehow. Well, the best way of getting rid of a negative 5 is to add 5 to it, so I'll do that. So I will add 5 to the left-hand side. But if I want the left-hand side to stay equal to the right-hand side, whatever I do to the left, I have to do to the right. So I'm going to have to add 5 on the right-hand side as well. And so on the left-hand side, I'm left with a, and then the negative 5 and the positive 5 cancel out. And on the right-hand side, and they're going to stay equal because I did the same thing to both sides, we have negative 2 plus 5, which is equal to 3. So a is equal to 3.
Now, once we have a equaling 3, what can we do with our answer?
You can put it on the problem.
I can put it in the equation, right?
Yeah.
So then I can go ahead and plug where a is, put my number 3 in, and 3 minus 5 does equal negative 2. Now, it seems really simple with these smaller numbers, right? So, but if we get bigger numbers, now we know the order of operations and how to do this. Okay?
Once again, you can verify it. 3 minus 5 is indeed equal to negative 2.
All right.
Solve for a and check your solution. We have a plus 5 is equal to 54.
Okay, so here's a sample problem. We're going to solve for a, and then we're going to check our solution. So since Connor just went, Lily, do you want to go up to the board?
Yeah.
All right.
A plus 5 equals 50. And minus 5 is 5. This was a 5. And put a right here. Equals 54 minus. And 50, right?
Why don't you take your calculator? Try it on your calculator.
Okay.
So you can take the eraser, and you can just erase. There you go. 49. Now what I like what you did is that you used the inverse operation and then you cross it out to get a by itself, right?
Yeah.
Now it says solve for a, which is what we did.
Yeah.
Now how do we check our solution?
You would take this number and put it in the...
Why don't you go ahead and do that? Take your 49.
Should I put it like right here?
Sure, you can underneath there, yeah.
49 plus 5 equals 54.
54. Okay, great. Now, do you need to do that on your calculator, or do you know that that's right?
Oh. 49 equals 54.
Okay, great job. Now, one of the neat things about Khan Academy is not only do we have the lessons that go over like the math concepts we're learning, but you can also pause your videos. You also can check to see if your answers are correct. So we can go through.
Now all this is saying is that we have some number,
listen
some
to the
variable
instruction.
A, and if I add 5 to it, I will get 54. And you might be able to do this in your head, but we're going to do it a little bit more systematically because that'll be helpful for you when we do more complicated problems. So in general, whenever you have an equation like this, we want to have the variable. We want this A all by itself on one side of the, on one side of the equation. We want to isolate it. It's already on the left-hand side, so let's try to get rid of everything else on the left-hand side. Well, the only other thing on the left-hand side is this positive 5. Well, the best way to get rid of a plus 5 or of a positive 5 is to subtract 5. So let's subtract 5. But remember, this says A plus 5 is equal to 54. If we want the equality to still hold, anything we do to the left-hand side of this equation, we have to do to the right side of the equation. So we also have to subtract 54 from the right. So we have A plus 5 minus 5. Well, that's just going to be A plus 0, because you add 5 and you subtract 5. They cancel out. So A plus 0 is just A. And then 54 minus 5, that is 49. And we're done. We have...
So he just said A equals 49, which is what you got. But now he's going to go ahead and go through and check his solution.
solved for A. A is equal to 49. And now we can check it. And we can check it by just substituting 49 back for A in our original equation. So instead of writing A plus 5 is equal to 54, let's see if 49 plus 5 is equal to 54. So we're just substituting it back in. 49 plus, let me do that in that same shade of green. 49 plus 5 is equal to 54. We're trying to check this. 49 plus 5 is 54, and that indeed is equal to 54, so it all checks out.
All right, we're going to go to our next video, which talks about division. So when we're talking inverse operations, for adding and subtracting, they were the inverse of one another. So now if we have division, do you know what the inverse operation of division will be?
No.
What's the opposite of dividing?
Multiply.
Multiplying, okay? So the inverse operation for these equations will be either division or multiplication, all right?
Let's say we have the equation 7 times x. 7 times x is equal to 14.
Okay, so we have this equation right here. 7x, or 7 times x, is equal to 14. So if we're going to do the inverse operation, and this is times or multiplying, what do we got to do to get what by itself? Are we looking to get x by itself? So what do we need to do?
Divide.
Divide. So I'm going to go ahead and I'm going to come over here, I'm going to write it out. 7x equals 14. So I'm going to divide. What am I going to divide by?
7.
7. Now do I just do the one side?
No, you do both sides.
Okay. If we do something on one side, we got to do it on the other side. So then x equals 14 divided by 7. Do you guys know that?
7.
You think it's 7? Why don't you use your calculator? Check it out. You know what it is, Connor?
Equals 2.
Equals 2. So Connor, you can grab a calculator and make sure you have one handy, okay? All right, so x equals 2. Now if we're going to go ahead and find the answer, what should we do once we found what x is?
You won't take. You will put it in the problem.
Yeah, I can go ahead and just plug it right back into my problem, okay? So then I would have 7 times 2 equals 14. And can we check that very easily? Yeah, we can check that very easily with our calculator, okay? Now, one thing I want to show you we had the variable x right here. Sometimes people will use the multiplication sign as an x. Can that get confusing?
Yeah.
Yeah. So that dot also means multiply. Okay? So this is a one-step division equation. All right? Okay, so we're going to go ahead. I'm going to clear what I just did because I know it is correct. We're going to skip ahead to the next equation. All right? So we have 3x equals 15. Does one of you want to go to the board? Go ahead, Lily.
Sorry.
It's okay.
I'm just gonna
That's fine. Excellent. And you're just going to plug it back in. So 3 times 5 equals 15. Is that correct? What do you think, Connor? Can you check it for her?
3 times 5.
Yes.
Yeah.
Awesome. So great job. Now the cool part is, Lily, I can already tell you that that is correct. But what if you were doing this on your own? You know, you don't necessarily have to do it on the smart board, but what if you were doing this on your own? That's where you come
But if
and press play on
you just
here.
wanted to do this systematically, and it is good to understand it systematically, you say, okay, this thing on the left is equal to this thing on the right. What do I have to do to this thing on the left to have just an x there? Well, I have just an x there. I want to divide it by 3. And my whole motivation for doing that is that 3 times something divided by 3, the 3's will cancel out, and I'm just going to be left with an x. Now, 3x was equal to 15. If I'm dividing the left side by 3, in order for the equality to still hold, I also have to divide the right side by 3.
Now that's a big concept. Am I right?
Yeah.
What you do to one side, you always do to the other side. Okay?
And what does that give us? Well, the left-hand side, we're just going to be left with an x, so it's just going to be an x. And then the right-hand side, what is 15 divided by 3? Well, it is just 5.
So boom, we got the answer. All right? Okay, now, that's one-step division equations. We're going to go to the next video, which is a one-step multiplication equation. Connor, you want to go to the board and try this?
Sure.
All right. So can you read that equation for me? What's it saying?
X divided by 3 equals 14.
Awesome. Why don't you go ahead and rewrite it? Okay, so what are we going to do if we have a division? You're going to multiply it, right?
So,
Does that seem right, Lily? X times 3?
Let me see. No.
No? So go ahead. You don't have to erase anything. Put your x over 3. All you forgot was the over 3 part. Add that right there. Does that make sense?
Mhm.
Okay. And then put your equal sign. Okay, go ahead and finish it out. Okay, so let's go ahead. Why don't you erase what you just wrote right there, and we can walk through it, okay? All right. So I have x over 3, and we're going to times it by 3 because we know that it's the inverse operation. What are you going to do with your number 14 there? Do you need to keep that 14 in your equation?
yeah.
Yeah. So go ahead, write your 14. Now, if we multiplied one side by 3, what do we got to do to the other side?
You do the same thing.
Got to do the same thing, all right? So you don't have to rewrite anything. Where else do I need to multiply by 3, Connor?
Over here.
Yes. Yep, so why don't you add that in? Times it by 3, right? Okay, so do you need to grab your calculator?
Oops.
That's all right. Just take your times 3, add that back in. Okay, so we got an issue going right here, Connor. Let's just back up, because I think I know what you're trying to accomplish here, but it's looking a little bit messy. So here, I'm going to grab this. Okay, so whenever I have my x over 3 equals 14, I'm going to take both sides times 3. Did I just take both sides times 3? Right here and right here. So what do I want to do with these?
Cross.
Cross them out. So what I'm left with is x equals 14 times 3. X is going to equal what? Once you do your calculation. And you got what?
42.
42. Now what do I need to do to check to see if I got the correct answer?
You will put the 42 on the problem.
Go ahead. So why don't you put the 42 in the problem, Connor? You can just write it anywhere, it doesn't matter. 42
Divided by 3.
divided by 3. So 42 over 3. And that would equal 14. So do you want to check that on your calculator and see if that's right? So is that right?
Yeah.
Awesome, thank you. Okay, so now the best part is on this Khan Academy, don't erase it, just leave it. We can check to see if we're correct. So let's see.
Solve for x and check your solution. We have x divided by 3 is equal to 14. So to solve for x, to figure out what the variable x must be equal to, we really just have to isolate it on the left-hand side of this equation. It's already sitting there. We have x divided by 3 is equal to 14. We could also write this as 1/3 x is equal to 14. Obviously, x times 1/3 is going to be x over 3. These are equivalent. So how can we just end up with an x on the left?
So he just showed you that x over 3 is the same as 1 over 3 times x. There's multiple ways in which we can write that. But I think that sometimes working with fractions like that can be confusing. But if that's something that makes sense to you, then you can rewrite it like that as well. Okay, so there's 2 options there.
Left-hand side of either of these equations. These are really the same thing. Or another way, how can we just have a 1 in front of the x? A 1x, which is really just saying x over here. Well, I'm dividing it by 3 right now, so if I were to multiply both sides of this equation by 3, that would isolate the x. And the reason that would work is if I multiply this by 3 over here, I'm multiplying by 3 and dividing by 3. That's equivalent. That's equivalent to multiplying or dividing by 1. These guys cancel out. But remember, if you do it to the left-hand side, you also have to do it to the right.
So what he's saying is, if I'm going to multiply by 3, that is the inverse operation of the x divided by 3.
Yeah.
But what I do to one side, I also do to the other.
Yeah.
Now, is this being reinforced with you? Okay, so these are just one-step equations where you're doing the same to both sides. When we get to those multiple step equations, it's really important to remember these steps. Okay.
Hand side. And actually, I'll do both of these equations at the same time because they're really the exact same equation. So what are we going to get over here on the left-hand side? 3 times anything divided by 3 is going to be that anything. We're just going to have an x left over. on the left-hand side. And on the right-hand side, what's 14 times 3? 3 times 10 is 30. 3 times 4 is 12. So it's going to be 42. So we get x is equal to 42. And the same.
All right, so we got x equals 42. And that's what Connor shows in his work down here. X equals 42.
Thing would happen here. 3 times 1/3 is just 1. So you get 1x is equal to 14 times 3, which is 42. Now let's just check our answer. Let's substitute 42 into our original equation. So we have 42 in place for x, over 3 is equal to 14. So what's 42 divided by 3? And we could do a little bit of, I guess we call it medium-long division. It's not.
Okay, so we're going to stop right there. He just checked his solution, and he is correct. Now, with numbers like these that are a little bit smaller, it's pretty easy. But what happens when we get into larger numbers? Is it important to check your answers? Okay, the other thing I want to say is, why else is it important for us to write out our steps, each step, what we do?
Because that way we can see if we did it right or not.
Yeah, we can see if we did it right, and if we did make a mistake,
we can go back and fix it.
Exactly, we go back and fix it. I maybe can help you see where your mistake was, and sometimes if it's a recurring theme, that's something that we can really work on and focus on. Okay? Do you guys have any questions over what we just went over? No? You feel pretty confident in this? All right. Now what happens next is we're going to actually do a little bit of independent practice with our one-step equations. So what I want you to do, I sent you an email out. I want you to open your computers up, and it's going to be a link to practice questions on Khan Academy. And so you guys can go ahead, open up that link, and then I'm going to have you do your equation work on the whiteboards. So I got whiteboards and whiteboard markers there for you. So if you scroll down, right here, math, Khan Academy. Just go ahead and click on it. All right, so once you grab a whiteboard, so then you go ahead and rewrite your equation and do it out. When you have your answer, plug your answer in, and then down here at the bottom you check your answer. Lily, do you see that?
What?
When you get your answer, you can plug it in here, and then you go down and you check your answer. Okay? All right, so it says good work. So you go to the next question, and we have another one. All right, good job. All right, now what I think I'm going to do, I feel like you're really confident in your addition and subtraction, is if you come down here, we can practice so we can practice our one-step
Yeah.
multiplication and division equations. Okay? All right, good job. Now I'm going to go ahead and have you, since you got the addition and multiplication down, let's go ahead and let's go to practicing one-step multiplication and division ones. Okay? So here you go. We're going to move on to this part. Good job. You feel pretty confident in this, Lily?
Yeah.
Yeah? Can I throw something at you now?
Sure.
Okay. So if you go to here, the next step is two-step equations. Okay. And so this is actually an introduction to two-step.
Okay.
You can actually just go to the practice in 2 steps.
Okay.
Do you want to try it?
Mm-hmm.
All right. So these are also similar to what we did in math class today, right? We had
Yeah.
You have both. Okay. So go ahead and try. All right. So do you remember our vocabulary, Connor? Inverse operation. So what do we do? What kind of problem is this right here?
Division.
It's a division. So what do we do when we have a division problem?
Turn it 2 times.
Yep. And so what do we want to times first of all? What number? Mm-hmm. So where would we put that? Good. Over what? Not 3. 5. Equals what? 3. So if we did something to one side, what do we do to the other side?
The same.
Okay, so what do we got to do to the other side? Do you remember? So if we multiplied by 5 on this side, what do we got to do to this side?
The same.
Which is what?
3 or 5.
Which one is it? If we multiply by 5 on this side, what do we do to this side?
The same.
Which is what?
5.
Okay, times 5. So now we cross this off, right? And what are we left with? So we're going to go ahead and write this. W equals 3 times 5. So you can do that with your calculator, right?
Mm-hmm.
Okay. Go ahead, do that with your calculator and then plug it in and see if we're correct. Okay, now do this one on your own, all right?
Mm-hmm.
Did you get the first one right?
Yeah.
Okay, awesome job. All right, why don't you guys stop for a quick second? All right, so just to kind of wrap this all up, all right? What do we think about when we hear inverse operation?
Is when you do like the opposite thing, like
So if we have an addition problem and we want to do the inverse, what will we do?
no subtraction.
Subtraction, right? And the inverse of multiplication is?
Division.
Division, all right? And we will always want to make sure the variable gets by itself. Agree?
Yeah.
Okay, so our vocabulary word for today was inverse operation. Same thing Mr. Becker talked about in foundations today. Once we get really solid with our one-step equations, now we transition to two-step equations, right? And Lily, that's what I got you going on, right?
Mm-hmm.
Okay, Do you guys have any questions?
No.
All right. Do you think you could use Khan Academy maybe in the future?
Yeah.
Do you think that that's a pretty interesting way to learn?
Mhm.
Yeah, I mean, that's kind of considered a flipped classroom where the instruction is given to you, and you can even do it before you go to Mr. Becker's class, okay? And so as we try to build our skills, maybe we'll use Khan Academy more to reinforce those concepts. All right? Okay. Great job. Keep on working.